Okay, so let's do some TDD. As we saw when we run pytest, the output is nothing. So yes, information and then no test run. And this is because pytest, as I told you, tries to automatically discover tests. And there is a test file. So if you go into the test directory, there is a test calc file. But the file is empty. If you go with your editor inside the project and open the file, you see these are only comments. So there are no tests. What are tests in pytest? Tests are functions. Which name starts with test underscore is enough. So files, which name starts with test underscore, and functions, which name starts with test underscore. So if we want to run pytest, we have to start writing tests. But to start writing tests, we have to first understand what we are supposed to do. So let's go and read the description of the project. So in the README, you will find the description of the project. You can read it in your editor as well, if you want. So bear in mind, this is a beginner's workshop. So the project I selected is extremely simple. Do not expect anything fancy like web frameworks, graphical user interfaces, nothing of sort. So the project is just a small class that performs calculations. And this is, I did it on purpose because I want to focus on TDD. I don't want you to struggle with Python functions or clever solutions. This is not what we are trying to do today. So there will be time for smart Python solutions in other workshops. So without further ado, let's go on. Then the description of the project is the following. So the goal is to write a class calc that performs calculations: addition, subtraction, multiplication, and division. So it's a pure calculator. Addition and multiplication shall accept multiple arguments. That is, addition should be add 4 and 5, or add 4 and 5 and 7, or add 4 and 5 and 7 and 13 and whatever. So you should be able to pass as many arguments as you want to that function. Those functions, multiplication as well. Division shall return a float. It's a sensible requirement. And division shall return the string inf. A word on this. This is terrible. This is a very silly requirement. Never design a class that returns either floats or strings. Don't do it. This is a terrible API. I did it on purpose because this is the quickest way, I believe, to show you some features of pytest and of TDD. But yeah, I warned you, don't design anything like this, and don't go around telling people I taught you to return floats and strings. Okay? Thank you. So moving on, multiplication by 0 must raise a value error exception. And this is another silly requirement. So division by 0 is something you cannot do in mathematics. So it's sensible to do something different. But multiplication by 0 is perfectly legal, mathematically speaking. So this is a silly requirement. However, I have to say, maybe in our domain, multiply by 0 is not allowed. But yes, in this case, it's just something to show you how to deal with exceptions. The last requirement is that the class will also provide a function to compute the average of an iterable. So an iterable like a list, a tuple, a range, whatever, something you can iterate on, so you can run a for loop on that object. And this function, this average function, gets two optional upper and lower thresholds to remove the outliers. And we will see later what this means, because this is the very end of the workshop. Yes, let's start with the first requirement. The first requirement, which is to write a class calc that performs addition. So to do this, I open my editor. I open the file with my tests, get rid of whatever I wrote previously, and start writing functions to test the behavior. So the first thing I have to do, if I want to test a class calc performs if I want to test that the class calc performs addition properly, I have to import the class calc. So from pytest workshop dot calc import calc. This is the name of my class. I hear you screaming, there is no such a class. Yes, I know. PyTest workshop is here. The file is here because it's already in the repository, but the file itself is empty. I know. This is the main point of TDD. So TDD is test first, code later. So here we are importing a class that doesn't exist. This is already a test because the requirement says write a class calc. So pretending the class is there and we can import it, we can write a test. And as I said, tests in PyTest are functions. So def test underscore add to numbers. Yes. So let me write this for the moment. First of all, the function name has to start with test underscore. This way, PyTest can automatically discover it. The rest of the name is up to you. You can call it whatever you want. Obviously, as well, remember that naming is one of the most difficult things in computer science. People believe, the cloud, machine learning are complex stuff, definitely, but naming is very complex. So in this case, if we call it test 1, it's perfectly fine. Everything works. You can try it later if you want. The problem is when you have 200, 1000 tests running on your project, hopefully you will have one day, and suddenly someone changes something and test 1 and test 107 and 205 fail. What information do you get from these names? Nothing at all. Instead, if your test is properly named, you already know which part of the system you broke. So in this case, add the two numbers is a sensible name for this test. Let's move on and let's try something inside the test. So, I want to initialize the class. So C is lowercase c is my object, and then res result is c.add of two numbers 4 and 5. And let's stop here for a moment. Okay, look at this. So I decided there should be an add method inside the calc function. This is what I get from this requirement here. Nobody told me the addition method should be called add. You might say, okay, addition, okay, or sum. You are free to do it. actually you are free because this is a simple example. Generally speaking, you design your software before getting to the coding phase. Maybe you don't design it so in detail that you already know the name of all methods, but it might be the name of the method might come from the requirements. In this case, I'm free to do it, and feel free to call it whatever you want, just be consistent. And another thing you are creating on the fly is the API. So not only add as a name, but also how you are supposed to pass these numbers. I might say, okay, this works passing a list. This is a sensible API. Maybe not the best one, but it can be done in Python. There is no such a specification in the requirements, but there is nothing that forbids it. So basically, tests are the way you interpret your requirements. However, now that I have in res the result of the addition, I can write the proper testing code, which in pytest is an assert. And what are we asserting? That res is equal what we expect from that function. So 5 plus 4 is 9. And a word about assert. So pytest works with assert. Assert is a Python keyword that does a simple thing. It checks this expression, res equal 9. So assert expects a boolean, right? So you have a boolean expression here, something which is either true or false. If the expression is true, nothing happens. So the function goes on. In this case, nothing gets returned, so the function returns none. And that's it. Runs without any error. Instead, if the Boolean expression after assert is false, assert raises an assertion error, which is an exception. And this is how pytest works. So basically, if this function runs without raising any exception, pytest is happy and the test passes. Everything is okay. While if any part of this code, this or this, raises an exception, pytest considers the test as failed. So let's run the test and see what pytest thinks. I run pytest-svb and I get the big red thing. Cool. Okay, so I'm happy because the test fails. I told you in the introduction, I always expect my tests to fail in the first place. Because if the test doesn't fail, it means that you are working on something which is already provided, or that your test is wrong. However, you should, be aware that when the test passes, the first time you run it, you should be concerned. In this case, it fails, so we are very happy. And what goes wrong actually is not yet the test itself, but there's an error collecting the test. So what pytest does is recognizes the file, recognizes there's some code inside, tries to load the code, and it doesn't work because it cannot import the name calc. I know this is TDD. So we are importing something that doesn't exist. So cool. It works. It shows us that the class is not there. So what are we gonna do? Do you remember I told you write the minimal code that passes the test? Yes, I believe you remember. So what I'm gonna do is to go here and write calc. Yes, this is the class calc. So now Python can go and import it. Let's see if this is enough. I go back and run pytest again. Okay, it changed, which is good. It means that what we did somehow worked. It's also a bit less scary. Like this is, you know, the big red thing is a bit scary. This is a bit more ordered, you know, tidy. So we have here the list of tests, one test only for now, and it failed. And here we have some details about the failure. So the code of the test, mark on the line that fails, and the exception. And it says attribute error calc object has no attribute add. I know, again, this is TDD. I am using a method of a class, but the method is not yet there. So yeah, let's go and add the method. So the test complains there is no attribute add, so no function in this case. And yes, this is what I'm going to do. So def add self pass. I'm adding self because this is a method, so Python methods always want self, but I'm not putting anything inside the function because the test complains there is no attribute add. It doesn't say there is no function add that performs blah blah blah. It's just a matter of having the attribute so far. So let's run it again and see what happens. Yes, again it fails with a different error. Type error. Add takes one positional argument but 3 were given. I know, so I have this method accepts self only, but here I'm passing, well, self, you know, this is passed automatically by Python, is implicit, and then other two arguments, 4 and 5, and my function doesn't accept them. So yes, let's add them and say okay, self A and B. Is this enough? Let's see. So let's run pytest again. Oh, you're never happy. Okay, so now the test fails. Well, obviously it fails because we wrote some code here, but it actually doesn't do anything. So we were expecting the test to fail. And this is the last failure, hopefully, because it says, okay, you are asserting that result of this function is 9, but actually we get none because this function here passes, so it doesn't have anything, doesn't return anything, so Python by default returns none. And so you have the result is none, the expected result is 9, and yeah, they are not the same. So we have an assertion error, and this is the well, these are all test failures. This is, if you want, a failure of the assertion part. It shows you that everything is in place, the API is fine, the object is in place, but your code doesn't work as intended. Okay, so what shall we do? And this is the trickiest part of this first test, because every time I give the workshop, there is someone or all the attendees, they answer, well, you should go here and say return A plus B. But I say no, because we should write the minimal code. And if the test complains that we are not returning 9, we shouldn't return A plus B, but we should return 9. Okay, I hear you screaming, you are a crazy man. this is not good Python code, this is not getting anywhere, don't stop watching this video, bear with me. We are going into this because it's very interesting. It's an interesting part of TDD. First of all, let's see if this is enough, if pytest is happy with my code. So pytest, and finally, yes, we have the first test that passes. So test are 2 numbers, reassuring, green, everything is good. I like to see all these green passed. And by the way, this is what there is one of the reasons why I run pytest with -svv, because if you run pytest without anything, what you get is this. So test calc py, 1 dot for 1 test, 100%. It's perfectly fine. You can, maybe you prefer this one, maybe you prefer this one. You are free to do whatever you want. If you have many tests, maybe it's better to see a big line of sequence of dots. I somehow like to see all the lines with past. It's reassuring, it gives me confidence. And okay, so back to the return 9. Okay, so bear in mind this is a simple example, but you should try to abstract everything I say in this workshop and to remember that sooner or later in your career you will deal with complex systems. So we are writing something that adds 2 numbers here, but it might be something much more complex. So in this case, the complex system we are dealing with is the addition of 2 numbers. I know it's not that complex, but yeah, bear with me. And what you should keep in mind is your test battery, so that the group of tests you have, the whole set of tests, is asking you to return 9. This is what you wrote in your tests. If you go and write something more complex here, now you are you are giving yourself the task of maintaining this complex system. Again, bear with me, it's not complex in this example, but in theory, you might have something extremely complex there. Some function, some subsystem. You have to maintain it. And it's useless because your tests are not asking for it. It works, obviously, but it's not minimal. And my point is there should be a test that shows you later that this is not enough. That return 9 is not enough. If return 9 is not enough. Because if return 9 is enough for your system, that's it. Don't touch it. Don't make something more complex than required. That's it. This is the sermon for today. Let's move on. Because now we have, our first test passes. This is enough for me, and I'm very happy with what we did. Okay, so the next requirement is, we might go to subtraction, multiplication, or we can go on here. I prefer to skip this for the time being, and move to addition shall accept multiple arguments. So we don't add too many methods to the class, we don't overcomplicate things. So addition shall accept multiple arguments. And what does it mean? It means that I should be able to write something like add 4, 5, 6, or 4, 5, 6, 7, or 4, 5, 6, 7, 1, 2, 3, 4, whatever. As many things as you want here. Okay, so let's try it. Since we are doing it step by step, my first attempt would be to add 3 numbers. Let's see what happens. So yes, def test add 3 numbers. Sensible name, sensible spaces as well. So yes, again I do c equal calc shaded res equals c dot add 456 6 is perfectly fine, and then assert that res is equal 15. Yeah, sounds good. I have a new test, new function. The initialization part is the same. We call the function with 3 arguments this time, and then we do the assertion like we did before. Let's see what happens in the terminal. Okay, it fails. As I told you, I'm so happy when my tests fail for the first time. Perfect. It shows me that I exposed a missing feature. And in this case, yes, add takes 3 position arguments, but 4 were given. So yes, self plus these, and these are 4 arguments, but add takes only 3. Okay, so what shall we do? Well, one thing we might try to do is to do this, to add an argument. You know it's not enough, okay? But let's see what happens. So if I go back and run pytest, now I have 2 missing tests. 2 failing tests. So add 2 numbers and add 3 numbers. And the first one fails because, well, the addition requires a 3rd argument, and we are not passing it. And the second one fails for a different reason, which is that 9 is not 15. Okay, so let's check this first. And this is exactly what I was mentioning before. There should be a test sooner or later that shows that your solution, that your minimal solution is not good enough, if it's not good enough. In this case, returning 9 is not good enough. And you can see it here. You have, suddenly you want to, test another addition, 3 numbers or different numbers, and yeah, nothing works as expected. So this is fine. This other one is a previous test failing. And as a rule of thumb, you shouldn't have more than 1 test failing. In this case, it's pretty fine to have these 2 tests because these are the only tests we wrote. But sometimes you change something in the system and you have 100 failing tests. Suddenly, your test battery is like 1,000 of tests, and you may have hundreds of them failing because you changed something important, something in the core of the system. And personally, when I get these long lists of failing tests, I get, first of all, confused, and then also a bit depressed. It's like, oh no, I have, 200 failing tests. What did I do? And so it's easier for me to focus on one single test. And to do this, you can, one very simple thing you can do is to go, and it's perfectly fine to say, okay, let's comment this test out. And now we have only 1 failing test. Cool, yes, but in 2019 we might do something smarter. And pytest actually gives you many command line options, my advice is to go and check the documentation because it's very well written. In this case, my advice is to use the dash key option, which accepts a regular expression. So in this case, for example, I want to run only test add 2 numbers, and this is what pytest does. It goes and runs all. It actually runs all tests which name contains these string. So I might also say 2. That's the same thing. Okay, and this accepts expressions. So 2 or 3. Okay, so this runs all the tests. Sorry, this runs all the tests which name contains 2 or 3. In this case, both. So have fun with the dash key option. In this case, I prefer, usually when I want to run a specific test, I prefer to give the full name. So generally speaking, I hit exactly the test I want. So yes, okay. So we have only one test which is failing. I am very focused. I'm very happy. And how to solve this? Add missing one requirement position argument C. So yes, definitely I might go back to the previous situation, and this works, but this is a bit stupid because we changed it because we wanted to implement a new requirement. So yes, we can go back. Maybe it's what we did was wrong, but in this case we might try to find a new solution. And since the test says the argument is required, we know that in Python we might give a default value to the argument to allow Python to skip it. So C equals 0, for example. It's a sensible value. And now, my test passes. Amazing. I'm so happy. I have also to remember, however, now to go back to the full test set. And yes, okay, so the test add 3 numbers is still failing. Well, it's still failing because, we know 9 is not 15. And now, it's the time you finally can say, I told you, you had to write A plus B. I know. Now we have to write A plus B plus C. Okay. And let's see if this is good enough. Perfect. Again, if my test pass, my code is perfect. This is important to understand. So while you are wearing the TDD hat, so you are the tester, you are only concerned with passing tests. So as soon as your test suite passes, you are happy. That's it. Fine. Now I change my hat, I put the developer hat on, and I can say, okay, is this code beautiful? Is this code maintainable? Is this code good enough, smart enough, blah, blah, blah. In this case, it's good. If I gave C another default, like for example, none, I should here write some code like if C is not none, do this, else return A plus B. Okay, so as I said, this passes the test. Perfect. It's amazing. It's amazing in testing terms. If I go here, if this was like, some code that I wrote or that a colleague of mine wrote, I am in code review, I'm going to review this and say, well, yes, this is fine, but why are we doing it? Because if we do this, we can just remove all these lines, and now we have only one line to maintain instead of 4. And I check it, passes the test, amazing. Done. This is called refactoring. We are going to talk about it later. But yeah, okay, you got the concept, I believe. Cool. So now we have 2 tests passing. We checked that our addition accepts 2 and 3 arguments, but here it says multiple. So we still have something to test. Okay, so multiple arguments means 2, 3, 4, an infinite number of arguments. And this is one of the tricky things to test. It's actually impossible to test it properly because we should provide an infinite number of arguments, and this is impossible. So how do we test it? Because if we pass 1,000 numbers, so if we get here and we start saying, okay, let's say 7, 12, 33, 54, 62, blah blah blah, and I write 1,000 of them. These only tests that I can sum up 1,000 numbers. It doesn't show that you can sum an infinite number of arguments. And yeah, you have to accept this. So there are things that are not easily testable. There are things that cannot be tested at all. What shall we do? We should test sensible case. So we should find a condition which is reasonably representative of the case we are trying to test. And in this case, my approach is, well, we tested that we can add 2 numbers. We tested we can add 3 numbers. What if we add 100 numbers? If my function works with 2, 3, and 100 numbers, I expect it to work with infinite numbers. And if it doesn't work, it's because a problem in the language. Maybe Python runs out of memory because you are trying to add 1 million numbers, but it's not a problem for the code. So yes, I'm trying to find my way here. So okay, let's implement this that I say. So def test add many numbers, and again c equal calc res is equal c dot add. What shall we add? We should add 100 numbers, and yeah, I might write all of them. I don't want to do it, so what I can do is to say s equal the range of 100. This becomes a list of it's not a list, okay, it's a range of an iterable like 0, 1, 2, 3, and blah blah blah. Okay, this is what I get, and I pass here all the numbers, but pay attention, I cannot say add s because my add function wants all the arguments here. It doesn't accept one single iterable. This is not in the requirements. and this is how we decided to implement the class so far. So let's go on. How do we convert a range or an iterable, generally speaking, into a list of arguments with this notation in Python? So yes, res is the addition of all these numbers, and assert res equal 4950. I happen to know it. Yes, I did it before. And that's it. Okay, so this is my test. Let's see what happens when I run it. I didn't save, sorry. You see, I had, everything passed. If I said, okay, fine, let's move on. Well, instead, I expect the test to fail. So I saved, I ran pytest, and yes, it fails now. Fortunately, I can move on with the workshop. So the test add many numbers fails because add takes from 3 to 4 position arguments, but 101 were given. 101 because there's self, right? So self plus 100 numbers. And yeah, so what shall we do here? We might do this: d equal 0, e equal 0, and then at a certain point wrap up like, Excel style, AA equals 0, AB. I don't know about you, but I feel really stupid when I do these things. So this is a bad solution. I have to find some generic solution, and my generic solution has to pass all the tests. But don't worry, because focus on this one, because TDD is so your tests are there to check that your solution is correct. So if you write something wrong here that passes this test but doesn't pass the previous ones, well, you will see it here. So let's try. And yes, in this case, I know many of you already guessed the solution. We might accept a variadic number of arguments. And here we can write sum of s, which is this is built-in function in Python. Yeah, sounds good, but let's see what pytest thinks about it. Amazing, it works. Yeah, so cool. We have 3 tests. We test that we can add 2 numbers, 3 numbers, and many numbers. One small thing before we move on with the requirements. This test is redundant now, because if we can add 2 numbers and we can add many numbers, this is enough. So I might as well go and comment this out or remove it and say, okay, this is enough. For the time being, I'm gonna leave it there. It's a test we wrote. I don't really like removing them. But generally speaking, try not to have tests that are covered by other tests. So yeah, on a second thought, this is basically expressed by this. So I'm not gonna run it. I'm removing it. Let's do something new. Yeah, so we add the 2 numbers. We can add many numbers. We might remove these as well. But somehow, since we are testing multiple arguments, I want to test at least 2 cases. To say, okay, 2, 100, and there's a line that connects them, which means we can add up to infinite numbers. If we remove these, well, the only thing we know is that we can run, that we can sum 100 numbers. So at least 2 tests in this case. And that's it.